Hi everyone. Welcome to this session on Essentials of Computer Software Engineering, and today we'll walk through some of the most important concepts, principles, and applications of software engineering. Whether you're a student aiming to understand the basics, or a curious learner exploring how software shapes our world, this presentation will give you a clear and structured overview. Let's start with a quick introduction to software engineering. It's much more than just writing code. Software engineering is the systematic application of engineering principles to the design, development, testing, and maintenance of software. In the modern world, software is at the core of nearly everything: your phones, websites, cars, hospitals, and even smart appliances. The difference between programming and software engineering lies in the scale and structure. Programming is one part of the process, usually focused on writing code, whereas software engineering involves careful planning, documentation, collaboration, and long-term maintenance. The goal of this presentation is to help you understand how the software engineering process works, why it's essential, and how it continues to evolve. To keep our journey structured, here's the agenda we'll follow. First, we'll discuss the history and background of software engineering. Then we'll move on to the software development lifecycle, often called the SDLC. Next, we'll talk about the most commonly used tools and technologies in the field, followed by a discussion on real-world challenges and how engineers solve them. Finally, we'll take a look into future trends and innovations driving the industry forward. Now let's take a look at the background. Software engineering as a concept emerged in the late 1960s, during a time when developers faced what became known as the software crisis. It was first formally addressed during a NATO conference in 1968. At that time, software systems were becoming more complex, but there weren't enough structured methods to handle this growth. Projects would go over budget, face delays, and often result in low-quality software.
This led to the realization that software development needed to follow engineering principles, like those used in civil or mechanical engineering, to bring more discipline and reliability into the process. Over the decades, software engineering evolved into a core discipline within computer science, with defined methodologies, standards, and frameworks. This brings us to the main problem that software engineering aimed to solve. Back then, the software industry struggled with inconsistent quality, projects that went way over budget, and long delays in delivering working products. Maintenance and debugging were difficult due to poor structure and documentation. There was a clear need for a more organized approach, a system where every stage, from planning to testing, was defined and repeatable. That's what gave rise to structured software development models, quality assurance practices, and collaborative frameworks that are now standard in the industry.